Welcome back to ChemExam Explained, where the aim is chemistry clarity exam mastery. In today's video, we will be looking at CAPE Chemistry Unit 2, Module 3, 2024. Let's go. Question 3. The industrial synthesis of ammonia, known as the Haber-Bosch process, is depicted in the figure below. So here we have A, B, C, D, E, and F. Part A. Identify the species represented by the labels A, B, C, and D in figure 4. So for part A, you can write either nitrogen or hydrogen, and for B, you can write hydrogen or nitrogen. C would be the unreacted or the recycled nitrogen and hydrogen. So these were not used up in the reaction, so they were recycled. And of course, at D is where you convert your gaseous ammonia to liquid ammonia to remove it. 3. Part B. Use an equation with state symbols to indicate the process that occurs in vessel E in figure 4. Let's look back at vessel E. So remember now, we are forming gaseous ammonia from the reaction between your nitrogen and hydrogen. So we'll write that reaction here. So N2 gas plus 3H2 gas with the reversible arrow to produce 2 molecules of ammonia gas. Part C. Use the chemical formula and state the symbols to indicate the process that occurs in vessel F in figure 4. So let's go back to vessel F. So remember, after you form your ammonia in the gaseous state from the reaction of nitrogen and hydrogen, you have unreacted N2 and H2 that was recycled. What's left would be your ammonia gas that must be removed in the liquid form or the liquid state. So at D is where we have the gaseous ammonia being converted to liquid ammonia where it can be removed. So for our answer, we have gaseous ammonia forms liquid ammonia. D. The reaction to form the ammonia product is favored towards the formation of the product under certain reaction conditions. 1. State Le Chatelier's principle and use it to explain how increases in the pressure of reactants support the formation of the ammonia product in the Haber-Bosch process. So let's define Le Chatelier's principle. So this states that if a system is in equilibrium and a change in concentration, temperature, or pressure occurs, the system will act in such a way to oppose the effect of the change and return to equilibrium over a period of time. Here we see that we have 1 mole of nitrogen and 3 moles of hydrogen, which gives us 4 moles of gases on the left-hand side. On the right-hand side, we have 2 moles of ammonia. So on the right-hand side, where we have the lower number of moles, that would give us the low pressure, and the side, which is the left-hand side, with the higher number of moles, would give us the high pressure. Please remember that pressure and moles are directly proportional. So where we have the higher number of moles, that's where we'd have the higher pressure. So increasing the pressure on the system in equilibrium would favor a shift to the right, producing more ammonia gas. 3D Part 2. Identify the unique feature of the starting reactants that is mostly responsible for the exothermic nature of the reaction. So in looking at the reaction, you see that we had nitrogen plus hydrogen. So the N2, which is nitrogen, the feature is that it has triple bonds, and these triple bonds are very strong. So the answer is strong triple bond in nitrogen. Part 3. State the reaction conditions that are specific to the Haber-Bosch process. So let's first look at the catalyst. So we have iron catalyst, or a mixture of iron in iron 3 oxide, or a mixture of iron and aluminum oxide. In terms of temperature, if the temperature is too low, the reaction would be too slow, which is not economically viable. So we go with moderate temperature, which makes the reaction a little faster than it would be if it was low temperature. So the moderate temperature would be 400 to 450 degrees Celsius or 500 degrees Celsius. In terms of pressure, because we have the higher pressure on the left-hand side, high pressure would favor a shift to the right, producing more ammonia. So we would use a high pressure of 200 atmosphere. 3D Part 4. Indicate how each component of the conditions stated in D Part 3 increases the rate of collisions of reactant molecules. So for the catalyst, which is iron, it lowers the activation energy, therefore increasing the rate of collision. For temperature, it increases the kinetic energy of the molecules, which increases the rate of collision. And for pressure, high pressure decreases the volume. You must remember that pressure and volumes are inversely proportional. So the high pressure decreases the volume and brings the molecules closer together, which increases the rate of collision. 3 Part E. The Haber-Bosch process generates 2% of the world's carbon dioxide emissions and consumes 1% of the world's energy. Indicate 2 ways in which carbon dioxide is emitted as a byproduct of the Haber-Bosch process. So burning of fossil fuels to power the generators produces carbon dioxide as a byproduct, as well as the steam forming of natural gas. This is what we use to produce the H2 gas to react with nitrogen to form ammonia. So that process produces carbon dioxide as well as a byproduct. 3 Part F. State the effects of the major limitations if the reaction in the Haber-Bosch process is done at STP, which is standard temperature and pressure. So if we use standard temperature and pressure, the reaction rate would be extremely slow because the temperature as well as the pressure would be too low. Effect 2, the reaction yield would be extremely low at standard temperature and pressure. So in order to get a better yield, we want to use moderate temperature and high pressure. So standard temperature and pressure is not the best condition to produce the ammonia we want by the Haber-Bosch process. 3 Part G. Identify 2 ways in which ammonia affects the environment. Alright, so ammonia is very soluble. So if it gets into the soil, it will be washed into lakes and rivers and cause eutrophication. In the soil, it will cause the pH of the soil to change. First, it will make the pH become alkaline, and after it forms ammonium ion, it would react with nitrifying bacteria, releasing H+ ions, which would now cause the soil to become acidic. So it changes the pH of soil. As well as, because ammonia is a pungent gas, it will affect the human respiratory system. 3 Part H. As a fertilizer, ammonia is generally used in the form of an ammonium salt. Part 1. State the reason for this. So ammonium salts are not volatile, that is, they do not evaporate into the environment easily. However, ammonia, which is very volatile, would evaporate easily from the soil. And so it's best to use the ammonium salt, which is more stable in the soil than ammonia. Part 2. Give the formula for any one of the most commonly used ammonium salts in fertilizer. So the most commonly salts used in fertilizers are ammonium nitrate, ammonium phosphate, or ammonium sulfates. This is the end of Cape Chemistry Unit 2, Module 3, 2024. Please remember to like, subscribe, and click the notification bell so that when new videos are uploaded, you will be notified. Thank you.